So now I'm going to switch to engineering analysis. And this is laid out in the PD&E Manual, Part 2, Chapter 3, which lays out the procedural requirements for engineering analysis and design during PD&E. Engineering and design analysis needs alternative analysis, considerations for build alternatives, comparative alternatives evaluation, value engineering, and selection of the preferred alternative, and documentation of the engineering analysis. The purpose of the engineering analysis in PD&E, well, it builds up upon the information developed and documented during the planning phase. The purpose of this analysis is to support the development of the project location and design concepts. It identifies project features essential to the assessment of the project, and also to assess the impacts on social, cultural, natural, and physical environments in the study area. It also seeks to balance the extent to which the project's needs are addressed, and to ensure project costs and environmental impacts are minimized. Further, the analysis establishes the necessary design considerations to support progression of the project from conceptual and preliminary design to final design. This effort requires coordination with other functional areas within the district and central office. And now I'm going to show you the steps in the engineering analysis process and the preparation of associated documentation. So we need to understand the project needs, of course, the data collection, establishment of design controls and criteria, conducting an existing conditions analysis, develop alternatives and evaluation of their performance and impacts, compare the analysis of alternatives, or evaluate the alternatives. And finally, the selection of the preferred alternative. The level of analysis depends on the size and complexity of the project. It depends also on the class of action. The analysis must be performed to a level of detail sufficient to assess effects on the social, economic, natural, cultural, and physical environment, and must ensure all alternatives are developed to the same level of detail. All right, so the project manager is responsible for timely coordination between staff from planning, design, environmental management, and other staff from various offices within the district to ensure proper development and evaluation of project alternatives. If the project requires a federal permit, there could be coordination with other federal agencies, such as the U.S. Coast Guard, Environmental Protection Agency, depending on the issues involved. Specific information on coordination with the district offices can be found in section 3.2.2 of this chapter. Right, so the alternative analysis is the process of developing, evaluating, and eliminating potential project alternatives. And this will be based on the purpose and need of the project. The alternative analysis involves the evaluation of both engineering and environmental aspects of a project. Therefore, it is important for the project manager to engage district engineering and environmental staff from the scope development stage through the alternative analysis process. It is also important to include public and stakeholder input when developing and evaluating alternatives. So what alternatives are to be considered? So we have 4 things that we need to consider for the alternative analysis. No action alternatives or no build, transportation systems, management and operations alternatives, or TSM&O, multimodal alternatives, and the build alternatives. The project manager reviews planning studies previously completed for the project and documents the alternatives that have already been considered, screened, and eliminated through planning process. So the no build alternative. Sorry, let me drink some water. My mouth is starched. Excuse me. Okay, so the no build alternative. This is the alternative in which the proposed project does not take place. So in other words, do nothing. It serves as the baseline for comparison with the environmental effects of the build alternatives. It must be analyzed to the same level of detail as the build alternatives. The analysis must include impacts to surrounding areas, and documentation must include the advantages and disadvantages of the build alternatives, and it remains under consideration throughout the PD&E study, including the public hearing. TSMNO alternative provides operational improvements that extends the service life of the facility while minimizing the environmental impacts. The TSMNO alternative may include upgrades or additions to the existing facility, such as ramp signals, work zone traffic management, road weather management, congestion pricing, among others. Prior to evaluating build alternatives, engineering analysis must demonstrate that maximizing the existing transportation system through various TSMNO strategies will not meet the purpose and need for the project. While TSMNO primarily relates to projects in urbanized areas, the concept of achieving maximum utilization is also important in rural areas. The alternative analysis should also consider multimodal alternatives, including non-motorized facilities for pedestrians and bicyclists. And for this, it is important that non-motorized facilities required to meet the purpose and need and to include facilities that are planned in the local government comprehensive plans, and also to include cost factors that require to meet the local needs. And finally, the build alternatives, which are proposed alternatives to address the project's purpose and need. They should seek to avoid or minimize impact to the environment by considering issues, concerns, and opportunities identified. And to ensure meaningful evaluation of alternatives, each alternative must have logical termini and should be of sufficient length to address environmental matters and the purpose and need on a broad scope. Independent utility, in other words, be able to function as designed and be reasonable expenditure, even if no additional transportation improvement in the area are made. When appropriate, consider opportunities for developing hybrid alternatives that could incorporate TSMNO strategies and or multimodal options with the build alternative to meet the purpose and need. The design detail of the build alternative should be commensurate with the information needed to define and evaluate the environmental impacts and to define the required right-of-way. Each alternative must be explored at a sufficient level of detail to support a recent choice. All alternatives under consideration must be developed to a comparable level of detail so that their comparative merits may be evaluated, and they should be documented as such. So the number of build alternatives analyzed during the PD&E study depends on the size and the complexity of the project. And here on this table, the number of alternatives required are listed per class of actions. For example, for a type 2 CE or for SEER, the minimum number of alternatives required is 1 build alternative and one no build. Again, it depends on the project. For an EA or environmental assessment, also 1 build alternative and no build. And for an EIS, the minimum number of alternatives would be a reasonable alternatives or reasonable range of alternatives, and the no build. So the no build is always in the formula. Okay, so the primary reason for eliminating an alternative from consideration is that it does not meet the project purpose and need. Although the no action alternative does not typically meet the purpose and need, it must be considered as a viable alternative throughout the project, throughout the study. The PER, or the preliminary engineering report, and the environmental document must include a section that discusses the alternatives, including TSM&O, which were considered for the project, but eliminated from detailed study during the planning or PD&E phase. This section should summarize the rationale for eliminating these alternatives, the criteria used, who was involved in establishing the criteria, and at what point in the project the alternatives were removed. So whenever the project includes a new or modified interchange, the alternative approved in the interchange access request, or IAR, must be included as one of the PD&E study alternatives. Also, safety, operation, and engineering, or SONE, acceptability should be obtained before NEPA document is sent to OEM for approval, or prior to final approval. The traffic operational analysis, safety analysis, and conceptual design analysis performed to address the requirements of FHWA policies on access to interstate system also support the development and evaluation of alternatives in the PD&E study. The preliminary engineering analysis for the PD&E study satisfies the old FHWA policy requirements. These are the ones that relate to social, economic, and environmental impacts that are no longer addressed in the IAR document. If the preferred PD&E study alternatives is different from the approved interchange concept, in the different type of interchange access request, then the interchange document will have to be reevaluated to demonstrate that the preferred alternative meets the requirements of the interchange access request analysis procedure. For this, it's very important that the PM coordinates with the district interchange review coordinator, or the DIRC, like we call them. So the project manager must carefully provide a balance between the environmental impacts, the engineering analysis, and the project cost, along with public input when selecting preferred alternatives. An analysis requires a comparative evaluation to objectively assess project alternatives at the same level of detail in matrix format. The objectives of an alternative evaluation matrix is to compare and contrast the performance of each alternative in meeting the evaluation criteria, and to quantify its impact to the natural, social, cultural, and physical environment. And this matrix must include the no-build alternative. Value engineering. So all projects except design-build projects with an estimated cost of $25 million or more are required to undergo at least one value engineering study, or VE, prior to final design. A value engineering study can be conducted during PD&E or during preliminary engineering design, or PER. If the value engineering study is conducted during the PD&E phase, it must occur after the alternative analysis is complete and before the public hearing. Also, the value engineering issues or recommendations should be resolved before scheduling a public hearing. The project manager then is in charge of coordinating, scheduling the value engineering study with the district value engineer, and make sure that the draft environmental document, the PER, and summary of public involvement and other technical documents are available for review by the value engineering team. Any recommendations from value engineering study must be incorporated in the comparative analysis evaluation and documented in the PER and environmental document. On the preferred alternative, the identification is based on the analysis of the project cost, environmental impacts, engineering analysis, and public inputs. The PER should discuss in detail the preliminary design features of the preferred alternative. So when once the public hearing is held and once the public hearing is held and public and agency comments are considered, appropriate sections of the environmental document are updated to include information received from the public hearing process. In addition, the PER is updated to include the preliminary designs. And on the blue box here is some of the design elements of prepared alternative. Typical sections, and you will see that in the PD&E manual, we refer to the approved or finalized typical section package. These are summarized in the PER and also attached to the PER or included in the project file. So I'm not going to go through all these. I'm trying to save some time for the traffic noise. And this is how the engineering documentation would look like. This is the PER or preliminary engineering report. Again, it's required for type 2 CEs, EAs, EISs, and this is basically the content. And there's more, all these information that I just shared with you is in more detail in the PD&E manual. So in conclusion, to be successful, there's got to be coordination, and the liaison and the link for this coordination is definitely the PM. The existing conditions analysis must identify the design and operational deficiencies of the existing roadways. The alternatives must be developed to the same level of detail, and unreasonable or non-viable alternatives must be summarized in the engineering and environmental documentation, and the development, analysis, and evaluation of alternatives must be presented in sufficient detail for the reader.